Hi, my name is Kevin Smith and I'm an Agile and Applications Engineer for Scopes. Today, I'm going to show how we can use the 3000X series scope to measure the startup time or settle time of a voltage control oscillator. This will be very similar for a PLL or DLL lock time measurement. I've already done a default setup, I've already deskewed my probes, and I've already compensated my probes, and they are hooked up to the device under test. I'm going to use the label keys to keep things obvious. On channel 1, I have my VCO. On channel 2, I have my voltage control, so I'll label that control. And I'm going to use the math function later, which is going to be a frequency trend. All right, so my particular device under test, I've set to loop on and off, on and off. So I could do a simple auto scale, but in real life, you may not be able to do that. You might have to throw a switch repeatedly. That might be painful. So you might want to know how to scale things automatically, manually. So channel 1, we'll just turn that on. There is my VCO. Want to make that bigger. Go to a finer scale. And generally, we'll want to get the startup on the screen. So move it a little bit to the left and put it in run mode. And we can see that there is, it's just kind of running by us. We turn on channel 2. As I said, this is the control signal. All right, and so this is really what I want to trigger on. Let's get it on screen. Now you might only have one shot at this, so you might need to know ahead of time, and we can see what our units are. But we want to trigger on channel 2. Just click on that twice, and we should probably put this into normal mode. So we only trigger on a rising edge on channel 2. And we need to adjust the level to something reasonable. And really, I want to get it at the rise of this signal. Okay, so we want to use a left reference, or move the delay to the left. Okay, and if we push this guy in, we can go to a fine scale. We just want to tweak this just to get the relevant information on screen. Great. Now I've used up a lot of the display, and that's a good thing. So I'm stably triggering on the start of my control signal. I have my VCO signal. Okay. Now what we want to do is we want to use the math function. We want to use the trend feature, measurement trend feature. This option does require the advanced math package on the 3000X series scope. This feature is not available on the 2000 series, but it is standard on the 4000X series. Okay, and it in fact defaulted to frequency. Okay, and now I can use cursors. Okay, if I put them into track waveform, I might want to do one of them on my control line, and the other on my VCO on the oscillator. Okay, so if I press the cursor knob, I can spin the cursor one way or the other to select which marker I want to use. I want to put marker 1, kind of at the bottom of this guy. And if the labels get in my way, I can simply turn them off by pressing the labels button twice. All right. Going back to the cursor knob, I want to go to X2. Press it again. And that's tracking my VCO. So if I press cursors again, I really want that to track my math function. Again, I really want my labels on. All right, so now, X2 is on the frequency trend, and I will move this marker over till we get into the stable region of the waveform. Stop this for a second and just kind of move it along here. When does this waveform really stabilize? Well, we can see that there is some bumpiness in here. This is largely a function of of the fact that I have phase noise, some large phase noise on this controlled oscillator, but the frequency is pretty stable at about 80 kilohertz. I'm sorry. Yeah, about around 80 kilohertz. And if we want to consider this to be the point at which it gets stable, from the time at which we fired up the voltage control, we can see that it took about 182 microseconds for this frequency trend to really flatten out. Okay, if we want to see what the range of frequency is, min to max, we can simply turn on a measurement of the peak to peak on the measurement trend. Okay, so we want to do where's our peak to peak? There it is. Just push that into select it and add measurement. All right, now really we can see that the markers have clicked to the absolute max and the absolute min, and that spreads over 20 kilohertz. But that's not really what we want to do. So what we can do is we can turn on the zoom feature, okay, and using the delay knob, move him way in here. In fact, we can do that a little faster by going to a let's unvernier this guy. Make the window way bigger. Move him to the center. There we go. To about the center. We can now go into vernier again. Okay. And if we go back to our measure button, settings, and we can gate the measurements to the zoom window, measure, and now we see we have a much smaller frequency spread than we saw earlier. We saw that we were at, earlier we had an 80 kilohertz spread representing from the absolute max to the absolute min, but we have about a 1 kilohertz spread. And again, this is due to some significant phase noise in this demonstration signal. Another neat thing that we can do with the math measurement trend is we could also even do a cycle to cycle average or RMS measurement. All right, and that automatically jumps the peak to peak to 15 millivolts of my AC RMS amplitude of the stabler part of the waveform. And that's the short version, or the long version as may be. Thank you for your attention.